We started exploring systems of equations yesterday, and we were solving them by looking at graphs or using the calculator. Today we're going to look at systems of equations and two other methods to solve them. We're going to look at a method of solving them called substitution, and the other one's called elimination. And the reason we show you three different methods is it depends on what they give you for the system. The systems they tend to work better one way or the other. You could use the same method every single time if you find that substitution is your favorite. You might do it on all of them. But you'll just notice that sometimes the systems of equations naturally fits to one way or another a little easier. So let's start with substitution. And on substitution, the biggest thing I want you to know is you've got to use parentheses. Anytime you're substituting, use parentheses. Even if you're just checking an answer, parentheses, always use your parentheses. That way you won't miss negative signs and positive signs that should have been there. So what we're doing is we're trying to find or get one of our two equations isolated for one of the variables. So in equation 1, it's already isolated, meaning the y is all by itself. So we know for sure that y equals negative 2x minus 9. Since we know that, we're going to be substituting instead of a y, we're going to put in negative 2x minus 9. So that's what we're going to use as our substitution. So we're going to do that in equation 2. So we're going to say 6x minus 5y, but instead of y, we know we're substituting in negative 2x minus 9. So minus 5y equals negative 19. And now we're just going to solve this thing. So the first thing we have to do in our solving is we're going to need to take care of this negative 5 and distribute it to both things inside the parenthesis. So we've got 6x, negative 5 times negative 2x is plus 10x, negative 5 times negative 9 is plus 45 equals negative 19. Now right here I have two like terms, my 6x and my 10x, so I can go ahead and combine them. That's going to be 16x plus 45 equals negative 19. And I'm going to go ahead and move my 45 over. And I've now got 16x equals negative 64. And when I divide both sides by 16, I get x equals negative 4. Okay, so now I know what x equals. I've got the first part of my ordered pair. So I'm just going to go back and I'm going to substitute my x value into my first equation to find out what y is. So let's see how that works. We're going to say y equals negative 2x, but instead of an x, we're going to substitute our negative 4. Negative 2x minus 9. Okay, so y equals negative 2 times negative 4 is positive 8 minus 9. So y equals negative 1. I write that as an ordered pair. My x is negative 4. My y is negative 1. And that's my solution. Okay, how would we check that to see if it's true? Well, the way that we would check it is we would go back to both of our equations and we would substitute the x and the y in for both equations and make sure they're true. So I want you to pause your video right now and just go check your solution in both of your equations and then start the video back up for the explanation. So when I plugged them both into both equations, they made both equations true, so we know it is the solution. Okay, number 2, again we're going to practice substitution, and we've already got our first equation. Our x is isolated, so that will be the thing that you substitute. So you're substituting for the x. You're going to replace it with 6y minus 7. So go ahead and solve number 2. Pause your video while you're doing it. and then start the video back up to check the solution. As long as you handled your negatives correctly and did your process, I'm sure you came out with the solution -1, 1. And then, since I had substituted in and was pretty confident with that one, I went ahead and took my point -1, 1 and plugged it back into my second equation just to verify that it was indeed the correct solution. Now, the last thing is just to make the connection to last class. These solutions, the -4, -1 from number 1 and the -1, 1 for number 2, what do they represent? Well, if we think back to last class, our solution was where our two lines intersected. So where we had two lines, our solution was the intersection. So these ordered pairs that we've been finding, these solutions, really just represent this point where the two lines intersect. It's the one point both equations have in common.